today my name is Renu Raman Sahu, and today we will be discussing assignment 3 of this year and assignment some of the assignment questions of previous year, which will help you to solve the current assignments. So the first question is uh, the energy eigenvalues of a particle of mass m confined to a rigid one-dimensional box of width L. So the energy values are given, and if the walls of the box are moved very slowly towards each other, then the rate of change of energy. Okay, so we have to find the rate of change of energy. But before that, we should know what the energies are for this particular system. So what is your system? The system is uh, actually one-dimensional box. So what we're going to do is just a second. Yeah. So this is the problem of a particle in a box. So in a particle in a box, what happens? You have a box, and that box. So here the potential outside it is infinity, and here you have no potential, 0, and the length of the box is L. Okay. So now, if the length of the box is L, you have to find the energy. So what kind of electronic states this can uphold? So one of the easy way to do this is by like one of the way is quantum mechanics, which is formal method is to you solve the Schrodinger equation. You solve Schrodinger equation, and solving the Schrodinger equation will give you certain energy levels. Okay, so the energy levels En is given by h bar square pi square n square by 2ml square, where see here m is the mass of the electron, and L is the length of the box, and n is your the state of the electron. So if you see n is equal to 1 is your ground state, and n equal to 2 is your first excited state. Okay, and so for these particular energies, the state of the electron will be given by psi n. So this is a wave function, and it will be given by 2 by L root under of sine n pi x by L. Okay, so for different n will give you different electronic states. So now let us suppose, so and what this will give, like the n equal to 1, it will give you, so suppose this is your particle in a box 0 to L. So n equal to 1 give you this kind of state. So this is 2 by L sine pi x by L. Then n equal to 2, you will have this. Okay, 2 by L sine 2 pi x by L. Okay, now so suppose let us say that you forgot this formula. Okay, then how do you get this formula? So how do you get this? So one way is by solving the Schrodinger method. How do you get this formula? So in case you forgot the formula, then what you have to do? You have to look at these electronic states. This is your n equal to 1 state. This is n equal to 2. Okay, so I'll draw this carefully. So n equal to 2 will look like this. So n equal to 2. For n equal to 3, it will look like so this will be n equal to 3. So what you observe here is that here the wavelength of this electron wave, lambda, let's so the L is equal to half the wavelength. So this is 1 by 2 lambda. Okay. Here L is equal to this is one wavelength. So L equal to lambda you can write. Okay. So this is 2 by 2 into lambda by 2 you can write. For here it is L is equal to uh, L is equal to, this will be 3 times lambda by 2. So basically what you get is L is equal to, for nth excited state, it will be n times lambda by 2. Okay. Now what you can do, now instead of L, we can just put uh, lambda equal to 2 pi by k. K is the wave number. Okay. Now if I put lambda equal to 2 by k, and energy E is equal to P square by 2m, this is energy, and P is equal to h bar k. So h bar square k square by 2m. Now what we will do is we will put for example here L is equal to n lambda by 2. Then what we will get here, n by 2, we will put this lambda, so we will get 2 pi lambda equal to 2 pi by k. Okay. And we want to get from this, so 2 cancels 2. From here we will get k is equal to n pi by l. So n pi by l. So now we will put this k in the expression of energy. So if we put this k in the expression of energy, what we get is E equal to h bar square pi square n square by 2m l square. So this is how you get this formula. So in case you so if you know this, then you don't have to like solve again and again the Schrodinger equation. So now what we will do, we have to actually find the time rate of variation of the energy levels. So how do we do that? So we got En is equal to h bar square pi square n square by 2m l square. The question has asked about n equal to 2, which means this is the first excited state. But there is nothing special about this first excited state. You can like do it for any like any state that is there. Okay, so for any given n you can do. For if the question asks you for third excited state, you can put n equal to so in that case you have to put n equal to 4. Okay, so first excited means n equal to 2, and nth excited state means n equal to, you have to take n plus 1. So let us do this thing. So first, for first excited state, n equal to, you have to put 2, E2. So it will be h bar square pi square, so 2 square is 4, so and 2 square is 4, 2m l square. So it is 2 h bar square pi square over m l square. Now we have to change. So what is happening? The question is asking how will the energy change if we change this L. Okay, so if the L we are trying to decrease. So let us say L is decreasing at a rate of dL by dt. Okay, so what we have to do, dE2 by dt is equal to 2 h bar square pi square by m, so d by dt of 1 by l square. So L is dependent on time, so 2 h bar square pi square by m, so this is this will be so since this is L square, right, so L square, if you do the derivative, so minus 2 by L cube dL by dt. Now you see, we can, what we can do is we can separate the variables. 2 h bar square pi square by L square. Okay, this is this expression. If you can see, it is actually this expression. This expression is here, and so we will put rest of the terms here by L dL by dt. So this we can write as again E2. So it is minus 2 E2 by L dL by dt. So your answer will be this one, minus 2 a2 by L dl by dt. Okay, so this is how you solve this question. And like there is nothing special about this n here. Like for any given state you can do this. Suppose den by dt you want to do, so what you have is uh, h bar square pi square n square by 2 m. So instead of L square, so what you so d by dt of again 1 by L square. So what you get is uh, h bar square pi square n square by 2m. So it is minus 2 by L cube dl by dt. Again you can write this as h bar square pi square n square by 2ml square minus 2 by L dl by dt. Now you see this expression is actually En. So this is En. So minus 2 En by L dl by dt. So for any given state, this would have been the expression. Like I hope this you could have done. Now we go to the next question. If you have anywhere any doubt, you can stop me over there. If somewhere you are not able to follow.
Sir, while we are doing the differentiating along with the L, we can do with the yeah, no, only L is there for the differentiate, right?
Yeah, see, all rest all the other things are constant. Mass of the
Yes.
electron is a constant, h bar is a constant, pi is a constant, and n is the number of states, so it is a
Yes.
constant.
Okay, okay, fine. So here there is given the depth of that L is known as that, right?
Yeah, so L is this width, and the question is
Okay,
asking the walls of the box are moved very slowly towards each other. So this wall is moving this side, this wall is moving this side.
okay, it is contrasting, right? Okay,
Okay,
yes.
okay. Now we go to the next question. Okay. So here what is asking, a particle of mass m is confined to an asymmetrical box of unit length in one dimension. It is described by the wave function. So you are given the wave function psi of x, and you are asked 8 by, so this is the wave function that it is given. Okay, some wave function of x, sine pi x 1 plus cos pi x. Okay, and so asymmetrical box of unit length. So what it means is, so asymmetrical uh, box, suppose this is your coordinate axis, okay, and your potential is defined. So this is your v of x, this is x. Asymmetrical box just means v of x of unit length. So it starts from 0 and goes to L equal to 1. So length, it is unit length, and the potential is infinity here, and it is 0 here. So that is your asymmetrical box of unit length in one dimension. Okay, and the mass of the particle is given. Mass of the particle is m, and it is described by this wave function. So it has already given this wave function. There is some particle which is this wave function. Uh, and so it is given. So this is the function for inside, and outside the wave function is 0, and we have to find what is the expectation value of the energy in this particular state. Okay, so how do we do this? So from, again we have to use, so here we have to use some quantum mechanics. Okay, uh, so from quantum mechanics, the solution of uh, the, like when you solve the quantum mechanics, so h bar square by 2m, uh, so 2 by 2x, 2 to psi by 2x square plus vx into psi x is equal to e of psi x. So when you solve this, you will get some psi and some e, and like they will be labeled by n, and it is just 2 by n psi n pi x by l So this you can get in, so this results you can get in any quantum mechanics book, Griffiths, or like any quantum mechanics book will give. So h bar square y square n square by 2 and l square. Okay, so this is the form of the in asymmetrical box of unit length, the wave function is given by sine. So what we will do, we will first so sine of n pi x by l. So what we will do, we will convert our wave function where all the terms would be some sine of something. Okay, so let us do that. So how would we do that? Is we just have to, so let us do this. Psi of x, and see the length is unit dimension, so it will just be putting l equal to 1. Psi of n will be square root of 2 sine pi x n pi x. So one of the beauty of this equation, like so what is the property of this 2 by l here? This 2 by l sine n pi x, so what it does is, if you do psi n into psi, uh, if you just do this integral mod square of this dx from 0 to 1 or 0 to l, this will give you 1. Okay, so these are normalized wave functions. These are normalized wave functions, and the probability of so we'll come to this. So why we want to put in this form square root 2 sine n pi x, because this is normalized. So we want to put this wave function in this particular form. Okay, so let us do that. 8 by 5 sine pi x. So I'll just open this bracket plus sine pi x into cos pi x. Okay, now here we what we will do, we'll do a bit more manipulation. Psi of x is equal to square root 8 by 5 sine pi x plus, so this you can write, so what you can do is multiply by 2 and divide by 2, and 2 sine pi x cos pi x is it is just sine 2 pi x. Now you see we have two functions. This is sine of n pi x where n equal to 1, and this is sine of n pi x where n equal to 2. Okay, so this we will write as new slide. So we have psi of x is equal to 8 by 5 sine pi x plus sine 2 pi x, and 1 by 2. So this is our wave function, uh, and we need a square root in front of it. So we will take the square root in front of it. So what we'll get, 8 by root 5, and we will divide and multiply by square root of 2, and 1 by square root of 2 square root 2 sine pi x. So this is one normalized wave function plus 1 by 2 root 2, and this is square root of 2 sine 2 pi x. So this is another normalized wave function. So if you integrate it from 0 to 1, it will give you 1. So now what we will do is we will just so if you take 8 by 5 into this, into the bracket, you will get 4 by 5 square root 2 sine pi x plus 1 by root 5 square root 2 sine 2 pi x. Okay, so this is your psi of x. Now you see here it is actually 1 pi x. So this is n equal, this particular wave function is n equal to 1. and this particular wave function is for n is equal to 2. So according to quantum mechanics, the probability that the electron is in this state, this energy state, will be given by the mod square of this, okay, mod square of its coefficient. And the probability that the electron is found in n equal to 2 state will be given by the mod square of this coefficient. Okay, so probability that energy of the electron, so if it is n equal to 1, en will be h bar square pi square by, so en will be actually e1 2m l square, and e2 will be h bar square pi square 2 square by 2m l square. Okay, so probability that energy is e1 is equal to mod square of the coefficient of this function. Okay, so it will be 4 by 5 square root whole square is equal to 4 by 5, and probability that energy is E2 will be given by 1 by 5. So basically it is the mod square of the coefficient of this, which is just 1 by 5. So now what we get is the expectation value of energy. So this we can say that this is P1 and this is probability 2. Probability, so expectation value is nothing but the average of this, like weighted by the probability. So expectation value is probability of in energy, probability of state is in electron energy state 1 into the energy 1 plus probability that the electron is in state 2 into energy E2. So this statement comes from the quantum mechanics. Now P1 is 4 by 5 into E1. E1 is what? So L equal to 1. So it is h bar square pi square by 2m. So h bar square pi square by 2m plus P2 is 1 by 5 and E2 is 4 h bar square pi square by 2m. I put L equal to 1. Okay. So expectation value of energy will be so for so this two will cancel this two, 4 by 5 h bar square pi square over m. So it is your 4 by 5 h bar square pi square over m. So this is how you solve the question. Okay. Okay, now we talk about the graphene. So what is graphene? Graphene is graphene is a two-dimensional material, and it consists of a single layer of carbon atoms arranged in a honeycomb structure. So yeah, so this is true. This is the structure of graphene, where each of this has a carbon atom, carbon atom, carbon atom, carbon atom, carbon atom. So this is how and this is in one dimension it is so in two dimension it is just this, you can extend it infinitely. So the correct answer is A only. So it is not a non-transparent material. Graphene, it is like the tube, a tube shaped material of carbon having, so this is carbon nanotube, not a graphene. Graphene is a planar material, two dimensional. Now we go to the next question. Okay. Now we go with the next question. Uh, the triangular Brillouin lattice is spanned by Brillouin lattice vector. So, uh, okay, you're clear about the previous question, right? Like, I hope that is clear. Uh, like, if you're finding difficulty in anything, you can just simply stop me. Okay, now we go to this question. The triangular Brillouin lattice vector is given, and you have already been given the unit vector along x and y, and we have to find the reciprocal lattice vector. Okay, so the way we do reciprocal lattice vector, this I will tell you the technique. Uh, in a two, I'll first tell you about the three dimension, and then I'll tell you how it can be done for a two dimensional case. So a1, it is some. So this thing has been given root 3 a ex. Ex is the unit vector along x direction. Okay, and a2 has been given. A2 has been given, and it is root 3a by 2 ex plus uh, ex plus root 3 ey. Okay, these are unit vectors. Let's say we have some a3 also. A3 is some vector. Let's say, okay, let us say this is a ez. Okay, so a is z. Now, what a reciprocal vector means? The definition of reciprocal lattice vector. Reciprocal lattice vector. So, a reciprocal. Let's say I want to find the reciprocal lattice vector of a1. So it will be b1. The property of b1 is such that, so if you do b1 a1 dot b1, then you will get 2 pi. But if you do a2 dot b1, then you should get 0, and a3 dot b1 you should get 0. Okay, or this can be written as uh, similarly, if you have, so whenever this is a1 and b1, you will get 2 pi. If these two index are different, then you will get 0. So the way we write is a n b b n prime, let's say a n dot b n prime is equal to a delta function n n prime. So this will be 1 only if this n and n prime are equal. Okay, now using this concept, we will find how, we'll try to get what is your reciprocal unit vector. So, so we define a reciprocal unit vector if we define it, let's say for example b1. So our requirement is, uh, so all you have to do is you have to find 2 pi times, so this is 1. So you, now let us, you have to write 2 index a2 cross a3. Okay, a2 cross a3 divided by, you want to find reciprocal vector of a1. So this is the reciprocal, so that is why you go for the other vectors. Write a1 in the denominator and dot it with whatever is there in the numerator, a2 cross a3. Okay, so this is how you will get b1. Similarly for b2, what you can do is, for b2 you write 2 pi, and since you want to find about 2, you can use the rest, a1 cross a3, a1 cross a3 divided by what you want, you will want a dot product of, so since this is b2, you write a2 dot whatever is there in the numerator, a1 cross a3. So this is how you do, and similarly for b3, b3 also you do the similar thing, b3. So this, since this is 3, we will leave that, and it will be a1 cross a2 and divided by a3 dot a1 cross a2. Okay, now since we have this uh, since we have this formula, now we can actually find, we can use these values, use a1, a2 and a3 to find what is a1 and a1 star or a2 star. Okay, so here it is defined as a1 and a2 star. So an a m, let's say m star will be delta n m. Okay, so now that is what we are going to do. uh, so we can take the cross product. If we take the cross product of, and we have a1 is equal to, just a sec, a1 will be equal to root 3a root 3a ex, and a2 is equal to root 3a by 2 ex plus root 3 ey. Okay, and a3 we are taking. So suppose it is asking for a 3 dimension, then you can simply take a3 to be, hello. You can simply take a3 to be, uh, yeah, a is it. Now we just do this dot product, and when we will do this dot product, so we do it with ex, ey, ez, and let us a2 cross a3 we want to find a2 cross a3. So this will be, a2 is this vector, so it is root 3a by 2, and root 3a by 2, ey is 3a by 2, and ex is 0, and a3 is 0 0 a. Okay, so this we have to take the determinant of, and we have, so we'll take this a, and it is 3a by 2 ex minus root 3a by 2 ey. Okay, and we want to find a1 dot a2 cross a3. So a1 dot a2 cross a3, that will give me a1. So a1 is this thing, so root 3a ex, so it will be root 3a, so since it is ex, it will only multiply with this ex part, so it will be 3a square by 2, so it is 3 root 3 by 2 a cube. Okay, now what we want is b1 will be equal to, so b1 will be equal to, so 2 pi, a2 cross a3 is here, we will take one a square outside, so a square will take outside, and it is 3 by 2 ex minus root 3 by 2 ey, and divided by, so it is 3 root 3 a cube by 2, 3 root 3 a cube by 2. So what we have is, now So this will just leave me with 1 by a, and this 2 will cancel with this 2, and so it is 2 pi by a 1 by root 3 ex minus 1 by 3 ey. So this is how you can solve for B2 as well. So it looks like uh,
So
yeah,
do we, do we know the formula we are using here as for to
as
know
per
the yes sir, this one 2 pi a2 cross a3 upon a1 dot a2 cross a3.
this one.
Yes sir.
So what do you know?
Sir, how we are using this formula means this type of concept, how we approach it.
Okay, how do we approach it? Huh? So why do we do this? Because you saw the definition, right? I'll just tell you. The definition is mm, so definition of reciprocal lattice is B and A M. So if you do a dot product, it has to be 2 pi delta Mn, right? So uh, if M is not equal to N, then this has to be going to 0. So this means 2 pi, uh, so this just means this is equal to, for M equal to N, this is 2 pi, and M not equal to N, it is 0. So what you do, if you define, let's say for example, let us check for this, for A1, you want to find what is B1. So if you so let us look for the cases where N is not equal to M. So N is not equal to M if and if you do a dot product, it should go to 0. So it can go to 0 if I have a quantity in the numerator which is perpendicular to B1, then the dot product will go to 0. And how do we get a perpendicular? So if I take a cross product of A2 cross A3, so by this we are making sure that this 1 is B1, or the reciprocal vector of 1 is perpendicular to both A2 and A3, and hence the dot product will go to 0. But now we want so we want it to be non-zero when it becomes so when it is perpendicular when it is so we want to be 2 pi when N is equal to M. Okay. uh, so in that case, if it is A1 dot B1, then sorry, so this has to be like this. So some form like this should have this has to be there. Now we want to impose the condition A1 dot B1 is equal to 2 pi. Okay, when will this happen? So when this will happen, because if A1 dot B1, so this is some scalar value, right? Some number, and that value we require it to be 2 pi. So what we will do, so we'll put 2 pi, and the rest of the factors, whatever that will come up, that should cancel. So if we start with this, so what we will get, A1 dot A2 cross A3. Okay, but that should be cancelled, or it should be factored out. That is why in the, so, and this can happen if in the denominator we put just this value, A1 dot A2 cross A3. Okay, if we just put this, then so this is again a scalar because this is a vector, this thing is a vector. So this will go away, this will go away, and we will be left with 2 pi. So like that is what we imposed on it, and we wanted to, and we got this particular form. Why? Because we imposed A1 dot A2 has to be 0, so which we get by this condition, and B1 dot A3, this has to be 0. So that is why and now you see, right, the how this particular form gives us the required required definition. So this is the definition of the reciprocal lattice, and the form which satisfies this definition is this particular form. So which one? Like B1 equal to 2 pi A1 2 pi A2 cross A3 divided by A1 dot A2 cross A3. You got it right? Why we use this particular form?
Mm, yes. Okay.
Yeah.
Actually, this 2 pi delta m is the primary thing we consider it, right?
Yeah, this is the definition. This is what we imposed and we got this.
Okay. Okay. Okay.
Okay. Yeah. So we go to the next question now. So here the Bloch's theorem is about the wave function of electron in it is stated as this. So this is the Bloch theorem. Which of the following is also an equivalent form of Bloch theorem? Uh, you have some question regarding this?
So this is similar to, sorry, this is for week 5 questions.
Uh, this is a week 3 question of this time.
Okay, it is similar like assignment 3, right?
Yeah.
Okay, fine, thanks.
Hmm. Yeah. So but I think this conceptually, you wanted to say something?
No, sir, we can continue now.
Okay. Yeah. Uh, okay. So the form of wave function. So what Bloch's theorem says is Bloch's theorem. It will tell you what kind of wave function. It will tell you uh, what kind of uh, wave function should be there. Wave function of the particle should be there if it is in a if the particle is in a periodic potential. Okay. So there are two equivalent form of the Bloch equation. So one is so Bloch's theorem it says so it is already given this particular part. Okay. Uh, so psi x plus a is equal to psi of x a to the power I k a. Okay. So whatever the form of the Bloch function is, it should satisfy this. Okay, and it has told that ux is a periodic crystal potential of this particular form. Okay, which has the periodicity of the what is a? A is the periodicity of the potential, periodic potential of periodicity a of periodicity city a. Okay. So it has already given the form of this potential. Uh, you have to see, you have to just plug in these values here and verify if this thing is correct or not. Okay. So let us first do that. So let us try first equation. So we have to evaluate this thing. Let us try to do for 3 if and check if it is coming out true or not. So so we're trying to do this. Okay. Psi of x, so it is given psi of x plus a. Uh, so here we don't see any a here. Okay, so uh, every translation it is independent of a. So this will not be a. So this cannot be of the form of. This cannot be any Bloch form. So you need to have some a dependence on left hand side and right hand side as well. You see this formula here. Here there is some x dependence. Okay. Here there is x dependence is there, and it has asked. But here you see. Let us try to do with this particular form. Okay. If you do psi of x plus a. is equal to u of x plus a e to the power I k a, and this is uh, u of x e to the power, so u of x, by using this thing, by using the this property you can write, and this is e to the power I k a. So what this statement says is, so this e to the power I k, it is a constant. Okay, since it is a constant, uh, now you try to do, uh, now what you want to do, you try to do psi of x. So you put, instead of x, you put x minus a, let's say. Okay, so x minus uh, sorry, a plus a is equal to u of x minus a e to the power I k a. Okay, so this will give you psi of x, and this will give you u of again x, because this is periodic, and e to the power I k a. Okay, but now you see, this thing is same as psi of x again. You understand why it is again psi of x? Psi of x, yeah, sorry, it is again psi of x plus a. You understand, right? Why it is again psi of x plus a?
No, sir. Actually, it is looking same to me. All the four options. I don't know.
No, 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 no. Okay, so uh, these are not same. Okay, oh. So here you see, there are no x, there is no x dependence here. You get it, right? Okay, I will tell what. So okay, you understood this third option, why it is not the, why it is not the answer, because here there is an a, there is no a coming into the picture here.
Okay. Okay.
You got it, right?
Yes.
Huh. Now here there is some a coming into the picture. Now let us try to analyze why it is not the answer.
Okay, sir. So in a statement, we can find it. It is stated as the phi x plus a is equal to phi x e to the power I k. So that is the same as like the third option, right?
It is same as that, like this option you are saying.
Yes. Acha, okay. There is phi, but here is u, right?
Yeah, yeah. So u is a different function. It is not the same. Okay, u is it is a function which is, it is just a periodic function in with a periodicity of the crystal potential.
Okay.
So
So
so what you should go about and do. So I will tell you with example 4 why it is not a, and then you can try with 2 and 1. Okay, this I will tell you how to do. Okay, uh, so you just remember psi of x plus a equal to u of x plus a into e to the power I k a. So psi of x plus a is equal to u of x plus a e to the power I k a. So this is nothing but u of x e to the power I k a. What Bloch theorem says you, I'll write the Bloch theorem so that you also understand. So psi of x plus a has to be equal to psi of x times e to the power I k a. Okay, this is what Bloch theorem says. But now what we are getting,
yes.
let us see. So let us first find what is psi of x. To get psi of x, you put x equal to, so instead of x you put x minus a, and see what you are getting. Okay, so if you put x minus a, you will get psi of x is equal to u of x e to the power I k a. So here you will put x equal to x minus a, so it is I k a. Okay, so this thing is again, since this is equal to this, so this is again equal to psi of x plus a. You understood, right? Because this thing is equal to psi of x plus a. Understood, right? Why psi of x is equal to psi of x plus a, which is not in the Bloch form. Not, so there has to be an e to the power I k a here, not in Bloch form.
Sir, actually, how we are transforming the u into phi or phi into u, that is
Phi,
giving some confusion.
phi into u. Oh, where is phi?
Means
Psi
okay,
into u.
okay. There is given block theorem, right? Phi that is in phi only.
So
Phi
yeah,
is equal to
yeah, yeah.
phi.
This is there in the question. So this thing
Uh,
has been given in the question.
so that is that the output is in phi term only, na? That phi x plus is equal to phi x dot e power I
Yeah,
k,
yeah.
right?
So here it has
So
to be psi x. Huh.
so when we are transforming into u, so what, how, which type of things it is going to transfer me? In there it is x only, but when we transfer to u, then it is comes with u x plus a, right?
I'll tell you.
Okay.
So psi of x, so if you do the Bloch theorem, it has to be of the form of some plane wave solution. So e to the power I k, and there has to be an x. So here is an x dependence. Here should be an x dependence. Okay. So here it was wrong because it was constant. Okay. So there has to be this x dependence, and it should be multiplied with a function of x again. It should be a function of x, but the property it needs to have is u. So if you translate it by x, where x is the periodicity of the potential, then you should again come back to this. So sorry, x plus a, it has to be equal to this. Okay. So this is the form. You understood?
But how so it could be u x plus is equal to ux?
Okay, so that comes from the derivation of in the proof of the Bloch theorem. So you have to take it as a, like you have to take it for a statement, and so there are multiple proofs of it. So in Ashcroft and Mermin you will get two different proofs, but to solve this particular problem you have to understand only this much. So only this part. Okay.
Okay, so,
uh, so you have to understand this part, like if you have already like this is the solution, actually solution of the problem, but I will show you how this is equal to this form. So these two forms are actually equivalent. Okay. So did you understand why this particular form is not the block for format? Because it is not satisfying this thing, this relation. You got it right?
yes.
So here we got just psi of x is equal to psi of x plus a. But what we want is, if you translate by a, then you will get psi of x plus this e to the power I k a has to be there.
Yes.
Yeah. So that is really important. Now I will tell you why this is an equivalent form. I'll go to question number 2. So you can try and check by the method that I tell you, that 1 and 4 will not be the option. Okay. So I'll tell you why the second one will be the equivalent form. So it has given psi of x is equal to u of x e to the power I k x now. Okay. And what Bloch theorem says, B L O H. So Bloch's theorem says that psi of x plus a has to be equal to, it is psi of x, but e to the power I k a. This has to be multiplied. Okay. So let us see what we get for this particular functional form. So if you do psi of x plus a, what you get? So you get u of x plus a into e to the power I k, instead of x you write x plus a. Okay. So u of x plus a, so according to the question, what is u of x plus a? U of x plus a, you can write it back as u of x. So you just write that this will be u of x into, so this is, can be written as e to the power I k x into e to the power I k a. Now you see this part. So this part is same as this part, right? And this is psi of x. So what you can write is psi of x, like here I have used this part. Okay, psi of x into this factor is there, additional e to the power I k a. Psi of x plus a is this. So this is what we see in the Bloch theorem. Okay, you got now why this particular form is your equivalent form, equivalent Bloch form. You saw, right, why it happened? Understood? Like, I hope that is clear. Okay. Um, was that clear?
Okay, yes.
ఏదైనా చూసుకోవడానికి వెళ్తున్నాను బాబాయ్ దగ్గరికి చేంజ్ నాకు నచ్చింది చేసుకునే స్వేచ్ఛ స్వాతంత్రం నాకు కావాలి కృష్ణ నాకు ఎదురు Yeah. Now we go to the next question. Uh, so here we are given uh, a wave function psi of x is a solution of Schrodinger equation with A, and the potential is symmetric. So what do we mean by symmetric potential? So let us say that this is V of x and this is x. So whatever the symmetric potential means, whatever the potential is here, this on the negative side also similar potential has to be there. Like so what it means is, mathematically, V of x has to be equal to V of minus x. So let us say, like, whatever at V of x you are getting this value, similarly at minus x also you should get similar value. So this is what a symmetric potential means. And it is said that psi of x is the solution of the Schrodinger equation with energy E. Okay. So what it is saying? Uh, so let us say that we have some solution of this equation. So let us say, so we write the Schrodinger equation first. Minus h bar square by 2m square psi of x plus v of x psi of x equal to e times psi of x. So if this equation is satisfied, then we say that psi of x is a solution of this equation. Okay, so I'll write it more explicitly in one dimension, dou x square. Now what you do? So what you put x equal to minus. So you transform x to minus x. So wherever you see x in this equation, you put it to minus x. Then what will happen? H bar square by 2m. So you see this is d by d of, so this is for double derivative, right? So you put minus x, dou by dou minus x. So wherever you see x, you put just minus x plus v of minus x psi of minus x is equal to e of minus x. Okay. Now this, what will happen is, so this is minus x minus s, so this minus minus cancels. So it is basically a double derivative with respect to x only. So minus h bar square by 2m root 2 by x square, and this will be psi of now minus x plus, since it is symmetric, we can use this condition. So this will be v of x times psi of x, and this will be e of, psi of minus x. This is e of a into psi of minus x. So we started with a, so what we did here, what we did was, we started with a solution of, so we say that psi of x is a solution of the Schrodinger equation with energy A. So if it is a solution, then it will satisfy this equation. This is the Schrodinger equation. Just again. Yeah. So we say that psi of x is a solution of Schrodinger equation. Okay. So if it is a solution, then it will satisfy the Schrodinger equation. So h bar square by 2m root 2 by 2x square psi of x plus v of x psi of x is equal to E of psi of E into psi of x. And what is the symmetric potential? Symmetric potential means V of x has to be V of minus x. So now what we do, let us transform this. So we'll take x to minus x. So we saw that minus h bar square by 2m. So the double derivative doesn't change its signs because it is dou by dou of x. It will go to dou by of minus x, which is minus dou by dou x. So if you to take a double derivative, so it just means minus dou by dou x of minus dou by dou x, which is minus 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 cancels and dou 2 by dou x square. Okay, so this doesn't change sign, but this will be psi of minus x plus v of minus x and psi of x, psi of minus x is equal to e into psi of minus x. Okay, now you see, this I can again change v of minus x by using the fact that it is symmetric. So what I will get is minus h bar square by 2m dou 2 by dou x square psi of minus x plus v of x into psi of minus x is equal to e psi of minus x. Okay, now you see, so psi of minus x, this is another function which is satisfying the Schrodinger equation. So uh, therefore psi of minus x is a solution. You understood this math, right? Why psi of minus x is a solution if v of x is a symmetric potential. I hope that is clear. Now, any linear combination of the solutions will again be a solution. So, if okay, if this one, yeah. So here we got to know that this is a solution. Psi of minus x is a solution. Now, any linear combination of the is there any doubt? Yeah, we'll go ahead.
Sir, here when we were find the del square upon del x square is positive after even putting in negative sign in there.
Yeah, yeah.
So why we are not taking here as a positive sign in the del square upon del x square, psi minus x instead of sorry psi x instead of psi minus x. Here we can say the last step.
Where? Which one?
As a last step here, it is written.
What do you
Yes,
want to
sir.
do?
Sir, psi plus x, positive x, because there we have find the symmetric potential with the positive in the del square upon del x square, right?
Yeah, yeah. So I'm not understanding your question. So what do you want to do?
Sir, here, so when we are putting the value of square upon del x square in negative sign, so
Yeah, yeah.
it should be it should be positive, na?
Yeah, it is
Because yeah,
positive, huh?
so but it is a minus negative only in the last step of your this
Oh,
solution.
this negative.
Yes,
No, no.
where I
This negative was already there from Schrodinger equation.
no, sir. Inside the del square upon del x square, psi under minus x. This one.
Okay, okay. So see, this psi of minus x, you don't know anything about psi of minus x, no?
No, sir.
So I mean, it is a unknown function. We don't know if it is a solution of the Schrodinger equation or not. So we have no idea if we have no idea if psi of minus x will be equal to, if it will be equal to psi of x or minus psi of x or 1 by psi of x.
Okay, okay,
What
sir.
is
Okay, sir. Then what we have changed means what we have put the del square upon del x square as a positive sign. What we have put right here in right side you have put that is positive coming.
yeah, so this
Huh.
negative thing, it will not have an effect on this operator. So if so what it means is, if x goes to minus x, then this double derivative will not change its form. It will be same as whatever it was there previously. So this has not changed. When we did this from x to minus x, it was still dou 2 by dou x square. So it was the same operator. Did you understand?
Okay, sir.
Yeah.
Yes.
Uh, like I hope that is clear.
Yes.
So basically, so we are changing this parameter x, but the operator is not changing. For example, like you can have uh,
Yes, I got it.
okay, fine. So now, given you have two solutions, any linear combination. So this Schrodinger equation, it is a linear equation. Linear equation in the sense, if so what is a linear equation? Uh, Schrodinger equation is a linear equation. So what it means, if let's say psi 1 of x is a solution, if psi 1 x is a solution, and if psi 2x is also a solution, then any linear combination. So any linear combination means, so any function of the form, let's say here a times psi 1 of x plus b times psi 2 of x, where a can be some real number, a can be any real number, and b also can be any real number. So this will be also a solution. So will also be a solution of psi of x, solution of Schrodinger equation. Okay. So basically you have two solutions, right? You saw that psi of x is a solution, psi of minus x is a solution. So any linear combination, let's say if I put a equal to 1, b equal to 1, and I just add them. So this will also be a solution. And suppose if I subtract them, so here a will be equal to 1, b equal to minus 1. So this will also be a solution. So not only that, any of the linear combination, let's say 1 by 3, 41. So any of these things can be, so any linear combination. So any solution of this form is also a solution, as long as these two individual functions are the solution. So here the answer is all of the above. And how do you check if it is a solution or not? As long as it will satisfy the Schrodinger equation. So this is how you solve this particular question. Okay. Now we go to the next question. It is saying, consider a linear lattice of length L, uh, with lattice constant A, considering the first Brillouin zone. The number of possible values in any energy band is equal to. Okay. So we want to count the number of possible values of k in any energy band. Okay. So the way we do this is like, so one of the way is uh, we can use the periodic boundary condition. Okay. So let us say we have a lattice of length L. So this is L. This is a lattice of length L, and it has some, it is composed of, so this distance is a, and there is a wave function on this lattice. Let us say it is psi of x. Now since this is periodic, what we will have is, we will have u, so psi of x, now you can use the Bloch theorem. So psi of x is equal to u of x e to the power I k x. Okay, where ux plus a will be u of x. Okay. Now what we do is we impose a boundary condition, psi of x plus L should be equal to psi of x. So this is the boundary condition. so this is in real space. This is in real space. We want to find what is it like in the what is it like in the k space. So and in the k space we'll look at the first Brillouin zone. Okay, so if you do this, so what we get is, let us impose this particular condition. What we have is u of x plus l e to the power I k x plus l is equal to u of x e to the power I k x. Now you see so this l will be equal to, if there are n times a, so it will be n times a. So if there are n of these lattice points, so that is why u of x plus a will again be u of x. Okay, by this thing. So e to the power I k x into e to the power I k l is equal to u of x e to the power I k x. So from here what we get, this u of cancel is ux, and e to the power I k x, e to the power I k x, this will be cancelled. So what you have is e to the power I k l is equal to 1. And from here what we get is, so 1 is nothing but 1 is e to the power I times 2n pi. Okay, so every integral multiple of pi will give you 1. So kl will be equal to how much? 2n pi. Now basically k will have a spacing of 2 pi by n. Okay, into n. Okay, yeah. So k varies in small discrete quantity of 2 pi by n. Okay, and the first so if you, so this is in real space. Now let us try to do in reciprocal space. In reciprocal space, so you will have a k space here k, so this was x. In k space there will be this k values, and all of these k values are separated by 2 pi by l. So this gap will be 2 pi by l. Okay, and what is the, like for a lattice constant a, the first Brillouin zone is given by so the first Brillouin zone is minus pi by a to pi by a. Okay, so that is the definition of that is the first Brillouin zone. Now we want to find the number of possible k values. So first Brillouin zone is, so this is in k space or reciprocal space. So if it is 0, it is pi by a, and it is minus pi by a. So this is your first Brillouin zone, and between this there are a lot of k values, and each of these k values are separated by 2 pi by n. So the number of k states will be equal to, what is the length of this first Brillouin zone divided by what is the spacing between these k values. So it will be, so what is the length of first Brillouin zone? It is 2 pi by a divided by 2 pi by l. So this is nothing but l by a. So your answer is l by a. Okay, like I hope that is clear. uh, so now let us go to the next question. So this question, you are given a translation operator and it is defined in terms of its momentum operator is like this. uh, so this is an operator t of x. So operator means it will act, so this x is a vector actually. So it is a an operator. So and it is defined as e exponential of minus I x I x dot P, so again P is an operator over H bar, then which of the following is true? So exponential, so what do you mean by exponential of this operator? So exponential of an operator, it just means so I hope you know the definition of what an exponential function is. So an exponential function is given by sum over n equal to 0 to infinity uh, x to the power n by n factorial. So it just means 1 plus x, so n equal to 0 it is 1, n equal to 1 it is x by 1, x equal to 2 it is x square by 2 factorial plus x cube by 3 factorial, and so on. So it goes on like this. So similarly, uh, an exponential operator, it just refers to uh, so it just refers to sum over n equal to 0 to infinity 1 by n factorial minus I x uh, p operator by h bar and its nth power. So this operator, so let us try to do this for, let us try to do this for a few values of n. So we put n equal to 0. So if we put n equal to 0, so 0 factorial is 1. I hope you know that 0 factorial is 1. So and something to the power 0, that is again 1. So this is nothing but a unit operator 1. Okay. Then we have the value 1. So after 0, so this is for n equal to 0. Now we put n equal to 1. So this is 1 by 1 factorial and minus I x dot p operator over h bar to the power 1. Okay. Then what we can have, then we can have higher order term, but you see everywhere there are only two terms, so we will just try to evaluate the second term. So for so in principle, what would have happened, the second term would have been the next term would have been 1 by 2 factorial minus I x cap dot p vector by h bar and again whole square. Okay. uh, uh, Whole square means this has to be operated twice. So this operator xp by h cross, this has to be operated twice. So we will not bother about plus higher order terms. We will not bother about the higher order terms. We will just look at this two. Okay. So uh, so what is this p operator? So I'll just come here. T of x is equal to exponential minus I x dot p by h bar. So this will be identity minus I by h cross x. So what is this p operator? So momentum operator p in real space will be given by p equal to minus I h cross gradient. Okay. So this is the form of the momentum operator. So what we'll do, minus I h cross then. Okay. So this has to be operated on some psi. So what we got here, plus higher order terms. So what we got here is T operator is identity operator minus I x by h bar. This is minus I h cross gradient. So this has to be this we need to operate on some operator. So we will try to operate this on psi of r. Psi of r. So when we operate this, t of x operator acting on psi of r will give me identity times psi of r minus, so this minus minus cancels, it becomes positive, and then there is this I square is minus 1, so minus, and this h bar cancels h bar, uh, and this is x dot gradient of psi of r. Okay, so this is nothing but psi of r. So the translation operator, it will just add some value to x, so it will just increment it in its argument. So identity times this is psi of r again minus x times this and psi of r. So this is what, and plus some higher order terms. So this will be your answer. Like, I hope that is clear. So it is asking about r minus x. So since it is asking about r minus x, you just uh, convert. Uh, so wherever there was x, you can take it to minus x. X goes to minus x. So what we get is psi of r minus x is equal to psi of r, and you see, if you go, this goes to minus x, so this will go to minus x, but again this delta, so if x goes to minus x, then gradient goes to minus of gradient. Okay, so why this is happening? So gradient is nothing but it is just dou by dou x, dou by dou y, dou by dou z, and if any of this, so x vector goes to minus x means what? So this means x goes to x, x goes to minus x, y goes to minus y, and z goes to minus z. So if all x, y, z goes to negative, then this also goes to negative, and this also goes to negative. Okay, so that is why this. But since this goes to negative and this also goes to negative, so these two cancel the effect of each other. R of Rn. So basically what we get finally is psi of R minus x dot del psi of R plus something. So your answer will be this. Okay, and this is not the answer. This is clear, right?
Yes, sir.
Okay, fine. Okay, now this is an interesting question. So what it is saying that there is a 3% decrease in the Fermi level. Oh, okay. So first I will explain you why should there be a decrease in the Fermi level. Like why, as you raise the temperature from uh, 0 to 300 degrees Celsius, so it has given you the volume coefficient and what it is equal to. Okay. So now you do you remember the expression for Fermi energy? So uh, the expression for Fermi energy. So if you derive it, it depends only on the number density of the electrons. Okay, so it is just h bar square by 2n and 3 pi square n. So this n is the number density of electrons, 2 by 3, where n equal to number density of electrons. Okay, so now in this formula you see there is nowhere, so I'll just write it as like this, 3 pi square n by v to the power 2 by 3. Okay, so here in this expression you see nowhere there is temperature. Okay, but how do you think that like on changing the temperature, you will see a decrease in the Fermi level. Okay, so what happens is it doesn't have a very explicit dependence on temperature. But what can happen because of the change in temperature? So if you heat a metal, it expands. So when uh, it will expand, you see the volume will increase. Okay, heat a material, heat a metal or increase temperature. So this will lead to expansion in volume, expansion in volume. So that expansion is volume is that is given by this beta. This is the volume coefficient. So with respect to temperature, how the volume is changing, that is given by this. Uh, and because of that expansion in the volume, what will happen is that the number density of the electrons, see, there are so the volume will increase, but the number of atoms in that volume or the number of electrons in that volume will not change. So that will see no significant. So n is a constant, but v is increasing. So that is why ef, so expansion in volume, and n is constant, it is not changing. So ef will naturally decrease. So now the question is, how do we solve this question? So what we will go what we will do is, uh, we have the expression of ef. ef is what? Ef is equal to h bar square by 2m into 3 pi square n by v to the power 2 by 3. Okay, so we want to find this quantity d, how this changes with respect to the temperature. Okay, so the only thing which is there and it can change is I suppose 3 pi square n. So this doesn't have a temperature dependence, 2 by 3, but volume has a temperature difference. So what we'll do, so we'll do d by dt of uh, 1 by v to the power 2 by 3. Okay, now this will be what, uh, so again, so we want to put it in some good uh, like we want to have a simple expression. So what we do is, we again divided by v to the power 2 by 3 and multiply v to the power 2 by 3. So you see, this part is again ef. So ef into v to the power 2 by 3, and this is d by dt times d by dt of 1 by v. So what we'll do, we'll use the chain rule. So d by dv of 1 by v to the power 2 by 3 and dv by dt. So this is what you can just do this. So this is what, d by dv of v to the power minus 2 by 3 is equal to minus 2 by 3 v to the power minus 5 by 3. Okay, so ef v to the power 2 by 3, so this derivative is minus 2 by 3 into v to the power minus 5 by 3 dv by dt. So here you see 2 minus 5 is minus 3 again. So it is ef, and minus 3 by 3 is 1, so it is v to the power minus 1. So ef by v minus 2 by 3 dv by dt. Okay, now what do you see here, so ef minus 2 by 3 1 by v dv by dt. Now you see this expression, this particular expression, that is nothing but, so 1 by v dv by dt, that is nothing but your volume coefficient. uh, so this is nothing but your volume coefficient beta. So what you have is, and what does this minus sign signify? This signifies that if the volume increases, the energy or the Fermi level will decrease. Okay, so this we have is from here dEf by dt is equal to minus 2 by 3 EF times beta. Okay, so now this also we can write 1 by EF dEF is equal to minus 2 by 3 beta times dt. This you can write from here. So what the question has given? The question has given that there is a 3% decrease in the Fermi level EF. So 3% decrease means what? dEf by EF is equal to 3 by 100. Okay, uh, as the temperature changes, so the change in temperature dt, it is given. So this 3% decrease is what? So 3% decrease means minus 3 by 100, and the temperature is raised, that means 300 dt is positive, 300 minus 0. Okay, so that is nothing but 300. So dt is 300 and dEf by EF is minus 3 by 100. So we'll just put that. So this will be equal to minus 3 by 100 is equal to minus 2 by 3 beta dt is equal to 300. Okay, yeah. So now what we get is this 3 will cancel this 3, and like I'll just do some calculation here. So from here we can get the value of beta. Okay, I'll just do this calculation. So it is minus 3 by 100 is equal to minus 200 into beta. Okay, so beta will be, so this minus minus cancels, 3 by 2 1. So this thing is, so beta is equal to 1.5 into 10 to the power minus 4. Okay, minus 4. So or it is 15 into 10 to the power minus 5. So 1.5 into 10 to the power minus 4 is nothing but like into 10 and by 10 you do, so 15 into 10 to the power minus 5. Okay, so this is how you solve this particular question. Now the last question, consider a solid of mass, okay, it has given already a molar mass. Okay, molar mass it has given 26.98 gram per mole, which forms a crystal with a BCC unit cell. So the BCC unit cell is simply this. So on every corner there will be every corner 1, 2, 3, 4, and at center there will be one more. Okay, so it forms a BCC unit cell and a lattice constant A. Lattice constant A means what? This side. So A equal to 331 ppm. Okay, so it is asking what is the density of the crystal in gram per centimeter cube. So how do you find that? Uh, so we are given this molar mass. Okay, uh, so let us find from that. So first we will get the number density of the number density of this solid. Okay, So to get the number density, we know that one BCC contains one BCC unit cell contains two atoms. So that means so why two? Because one from this body center. So this is actually one from the body center plus 1 by 8 from each corner, and there are 8 corners. So that is why it is two. Okay. Now it is two atoms. So the number density, number density is two atoms per how much volume? Volume is 331 picometer. 331 picometer. So 1 picometer is equal to 10 to the power minus 12 meter. So this is the volume. Okay, this is the number density. Okay, so so if this is the number density, we want to find the mass density. If two atoms is taking a volume of, this means two atoms is taking a volume of 331 picometer cube. That means one atom is taking a volume of 1 by 2 331 picometer cube. So that means Avogadro's number of atoms will take a volume of Avogadro's numbers by 2 into 331 picometer whole cube. This means, and if it is Avogadro's number of atoms, what would be the mass of Avogadro's number of atoms? It will be the molar mass. So it is 26.98 gram will take a volume of this. Okay, so what we have is, so I'll touch here. If so the number density n will be, this is number density again, number density, it will be mass times the volume. So mass is 26.98 divided by Na by 2 into 331 picometer. Picometer is 10 to the power minus 12 in whole cube. Okay, and so basically what you have to do is 26.98. Avogadro's number is 6.022 into 10 to the power 23 into 331 into 10 to the power minus 12, and you have to put a cube on it, and this by 2 is there, and when you solve this you will get the number density, and the number density turns out to be around so this number density will be coming in gram per meter cube. Okay, because you have converted everything to meter. So what you can do is, so this is 10 to the power minus 10 centimeter. Okay, so instead of this, if you put 10 to the power minus 10, you will get in gram per centimeter cube. Okay, so you will get around 2.47. So if you just evaluate this number, so if you just evaluate this number, you will get your relevant answer. You will get 2.47 gram per centimeter cube. I hope are these questions clear how to solve this? Like I hope it is clear. Now we can discuss some of the previous year's questions. We have still 15 minutes. So it is asking for the kinetic energy. So what are the questions here? The kinetic energy of the free electron at the corner M. So it is asking what is the kinetic energy of electron here is shown to be larger than that of X. So what is kinetic energy? Kinetic energy E is h bar square k square by 2m. What is k square? K square is nothing but h by 2m kx square plus ky square. Okay. So here you see this distance is what? Pi by a, and this distance is also pi by a. So kx, so at corner at m, kx is equal to pi by a and ky is also equal to pi by a. So and at x kx is equal to pi by a and ky is equal to 0. You understand this, right? So kinetic energy at m will be equal to h bar square by 2m. So you see kx is equal to pi by a, so pi by a whole square plus pi by a whole square. Okay. And kinetic energy at x, which is the uh, electron at x, it is h bar square by 2m and it is pi by a times whole square plus 0. Okay. Now what we have to find is uh, the ratio. So V is the ratio of kinetic energy at m divided by kinetic energy at x. So this amounts to you see this constant will cancel out and it is just 2 times pi by a. So it is just, let us try, by 2m into pi by a whole square plus pi by a whole square divided by pi by a whole square h bar square by 2m. This is nothing but 2. Okay. So this is how you solve this problem. Now it is asking, this is again the application of Bloch's theorem. For an electron moving through one-dimensional potential periodic lattice A. So you see this question is in the framework of the Bloch theorem. Which of the following corresponds to an energy eigenfunction consistent with Bloch's theorem? So energy eigenfunction means you have to just consider like what states you are using. So okay, let us first look at what these things. So psi of x is equal to a e to the power I pi by a x into e to the power I cos pi x by 2a. Okay. So this is a periodic function and it is e to the power I pi x by a. Okay. So what Bloch's theorem says? Bloch theorem says that psi of x is of the form of u of x times e to the power I k x, where u of x has to be equal to u of x plus a. Okay. So this is the condition of the Bloch's theorem. So if you, so here what is k? K here you see in this case k is pi by a. Okay. And so it has a periodicity of a. So you see this is supposed to be u of x. So now you check, is u of x plus a, u of x plus a is equal to u of x or not. Okay. So if you do here x, plus a, what you get here? E to the power I cos pi by 2a x plus pi by 2. Okay, so only this much you are getting. So this is uh, this is what you are getting. And if you evaluate this, what you get? You just get e to the power minus I sine pi x by 2a. Okay, which is not the same as which is not the same as e to the power. So basically this equality is not matching. So it is not the same as I cos pi x by 2a. Okay, so since this is not the same, so this equality is not holding, and hence this is not satisfying this is not consistent with Bloch's theorem. So what about this? So this we can say, so up to this part it is e to the power I k x. We have to see if this is periodic in A or not. So cos 2 pi by a, so instead of x we will write x plus a. So if it again comes back to 2 pi x by a, then we are fine. So this will be equal to cos 2 pi x by a plus 2 pi. So this is again coming back to cos 2 pi x by a. Okay, 2 pi x by a. So that is why now, so it is now satisfying this Bloch's theorem, because this will give u of x is equal to u of x plus a. So this will be your solution. Okay. So similarly, for similar reasons, this hyperbolic I, so this will also not match with the, so this is also not this is also not periodic in so this is also not of the form of this is not of the form of this Bloch's theorem. By similar reason, you can just check u of x plus a, is it again coming to u of x or not. This is how you have to solve this problem. Now it is asking, choose the correct statement about the Brillouin zone of a square lattice with a lattice constant a. The Brillouin zone of a square lattice is again a Brillouin zone. So how do you calculate the Brillouin zone of a square lattice? So for a square lattice, so in the real space will look something like this. So this will be a, so this will again be a, so this will be a. So you can write a1 equal to aex, a2 equal to aey, and if you solve, what you will get is yeah. So if you solve, you will get b1 is equal to 2 pi by aex, and b2 is equal to 2 pi by aey. So it is basically again a square lattice, and the areas of the first and the third uh, Brillouin zone is the same. Yeah. How do you know the Brillouin zones? So all the Brillouin zones will be of the same volume or the same area. So the way you do is, so you make this cells. So this will be your first Brillouin zone. So how you do? You connect all these dots or lattice to its nearest ones. So its nearest ones are this. Then you can also draw to the next nearest ones as well. And you take the perpendicular bisector. So this is one perpendicular bisector of this dotted line. This is a perpendicular bisector of this dotted line. This is a perpendicular bisector of this dotted line. So this is your first Brillouin zone, because you are taking the first nearest neighbor and you are taking the bisection. Then you take the next nearest neighbor. If you take the next nearest neighbors, then this is the dotted line and this is the bisection. then this is the dotted line and this is the bisection, then this is the dotted line and this is the bisection, and this is the dotted line and this is the bisection. So now this is your first Brillouin zone and this is your second Brillouin zone. Then for the third Brillouin zone, what you need to do? For the third Brillouin zone, you have to, and you see the area of this. So area of this, and this taken together will be same as area of this. So the first Brillouin zone has the same area as the second Brillouin zone, and similarly, you can also prove, like when you take the third nearest neighbors, then it will. Uh, so you can figure it out then, that it will also be equal to the third Brillouin zone and also be equal to the fourth Brillouin zone. So all the Brillouin zones will have the same area. So here this is an interesting problem. Uh, so so delta AB, it is defined as, so the definition is given. We will just have to solve this one. So how do we solve this? So in the next line we'll write, here you see, uh, in this expression has C, so delta BC and delta CA. So what we will do, so A B is equal to 1 to 4, so delta AB will keep and we'll just sum over C equal to 1 to 4, delta BC delta CA. Okay, this will be equal to what? uh, so this will be equal to, again, delta, so this CC, sum over AB is equal to 1 to 4, and this will be equal to delta AB, and this will be equal to, see, what we can do is, so this comes out to be delta BA again. Why? Because delta C equal to 1 to 4, delta BC delta CA. So I'll just show you, you can expand this delta B1 delta 1A plus delta B2 delta 2A plus delta B3 delta 3A plus delta B4 delta 4A. Now you see, if B is not equal to A, okay, if B is not equal to A, then this has to be equal to 0, right? Because if B is equal to A, then then it cannot happen that both of them are simultaneously equal to 1 or simultaneously equal to 2 or 3. So this whole thing has to be 0. But if B is equal to A, then what will happen? Then B is equal to A is equal to any one of these numbers. So any one of either, so A1 can either be, so either delta, so B can be either 1, or if B equal to A, if B equal to A, then either B equal to A equal to 1. If this is the case, then only this term will survive and rest other terms will go to 0. If B equal to A equal to 2, then only this will survive and rest other will go to 0. So that is why you see this thing is giving 1 when B is equal to A and 0 if B not equal to A. So that is why it is delta BA. Now this is what, now we can just simply evaluate. So only those terms will contribute in which, so again this will be what, delta AA, sum over A equal to 1 to 4. So if you sum over B, what will happen? If you sum over B, or what you can do is, you can expand all this, but if you sum over B, you will get this delta AA, and this is nothing but delta 1 1 plus delta 2 2 plus delta 2 3 3 3 plus delta 4 4. So this is 1 plus 1 plus 1 plus 1, which is nothing but 4. So this is your answer. So if you consider a band of anisotropic material, so this is a question which is there in the fourth assignment of this. So this we will not discuss, but I will tell you the general method. So the method is to get what is the energy, what is the number of states with energy less than E. Find number of states with energy less than E, and then take a derivative. Then number of states per unit form. Then take derivative with respect to E. So whatever the derivative that will give, that will be your density of states. So here is a question. It is asking, consider the charge of electron in one-dimensional lattice of lattice constant A. A small electric field E is imposed parallel to the lattice. So an electric field E, so if the electric field E is imposed parallel to the lattice, so the force will be what? The force on the electron will be, force of on the electron will be minus E times A vector. So force is nothing but momentum, dP by dt. So dP is equal to minus E dt. Okay. So now P is what? P is uh, P is nothing but h bar k. Okay. So h bar is a constant. So it is h bar dk equal to minus E dt. So dk will be is equal to minus E electric field by h bar dt. Now if you integrate from 0 to t, what you get is k as the function t minus k of 0 is equal to minus e t by h cross. So it is nothing but k of t is equal to k of 0 minus e t by h cross. So the answer will be k minus e t by h cross. So this will be your answer. So when the graphene was first isolated in lab, what technology or method did the researcher use? So the researcher used a method called peeling by a scotch tape. So they took a scotch tape and they peeled it off. So this is a question from the Fermi energy level. What is the probability? Okay. So in a solid, the energy level lying 0.01 electron volt below the Fermi level. Okay. What is the probability that this level remains unoccupied at room temperature? So the probability of occupation is given by this formula: a to the power e minus ef by kBt plus 1. So what you have to do, you put, so it is asking at the room temperature, right? So here you put T equal to 300 Kelvin. You know Boltzmann constant Kb 1.38 into 10 to the power minus 23. Okay. Now you know what is EF. Uh, so EF is not given, but what is given is that energy E is equal to 0.01 electron volt below the EF. So it is EF minus 0.01 electron volt. Okay. And since it is expressed in electron volt, what we can do is kBt at room temperature, it is 0.026 electron volt. Okay. So the probability that this level is occupied, 0.01 electron volt, this level is occupied is e to the power. So instead of here you will write EF minus 0.01 electron volt. So EF minus 0.01 electron volt, this EF will cancel EF by 0.026 plus 1. So this is the probability that this will be occupied. But it is asking what is the probability that it remains unoccupied. So for that what you have to do, 1 minus F of EF minus 0.01 electron volt. Okay, so that will give you 1 minus 1 by e to the power minus 0.01 by 0.026 plus 1. So this is what will, so if you evaluate this, you will get your answer. Which of the carbon allotropes can be formed by graphene? So graphene is this, so as you discussed, graphene is this two-dimensional material where all these coordinates will have, uh, so all these coordinates will have, uh, so here there will be carbon, 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 carbon. So it is a two-dimensional material. So it can form carbon nanotube if you roll this. It can form graphite if it is like stacked on top of another, and it can form something called fullerene or buckyball, which is like a spherical ball. So all of the above can be formed. So here it is asking choose the mobility of the conduction electrons in a copper conductor if in Hall effect measurements uh, performed in the magnetic field. Okay, so it is asking, okay, the transverse electric field strength. So we have to find what is the transverse electric field. Transverse electric field strength is turned out to be eta times less than that of the longitudinal electric field by electric field longitudinal. So eta is just uh, so eta will be this the ratio of this field. So eta, so or we'll write as et by el. Okay, so now what we will have is et is equal to, so this is a fraction, et is, okay, so the way we should go about it is like et is en divided by eta. So this means eta is e of the transverse field is eta times less than that of en. Okay, so here we are believing eta to be something greater than something greater than 1. So what is happening here is, so we have this material, okay, and there is an electric field developed due to the uh, due to the charge separation due to Lorentz force, and there is this so, so if current is going like this, electrons will be going like this. Okay, so there is this longitudinal field as well. This longitudinal field is applied due to the battery. Okay, so what we have to do, we have to find the and that battery or some power source will be there that is actually injecting this current, and if the cross section area is A, so J equal to I by A is the current density, and this is related to your drift velocity. J equal to NEVD, N is the number density. Okay, and uh, so the current, it is related with the drift velocity. Now What do we measure here is the Hall voltage. The Hall voltage is, it is given by VT, and it is ET times this distance D. Okay, so what do we have to find? We have to find the uh, mobility. So mobility is defined as the drift velocity by the electric field which is causing the drift. Electric field causing the drift. Okay, now the drift is caused by the longitudinal field. Okay, because electron is going like this. So this is a very famous formula, you should know this. V equal to A. V is equal to the drift velocity is electric field times mu. Mu is the mobility, or it is or basically mu is equal to Vd times El. Okay, Vd over El. Now uh, El we can get, what is El? El is nothing but eta times Et. Okay, so it is Vt divided by eta times Et. This is the transverse electric field. The transverse electric field is given by from okay, so from Hall from the concept of this balancing of the Hall field is given by this E transverse. E transverse is this field that has to be equal to E V B. So that is the magnetic force due to this magnetic field. So that is what it is causing the separation. So, so now from here this electron will cancel, and Et will be equal to Vt times B. So we just put that Vt eta times Vt times B. So what we got is mu is equal to, so this drift velocity cancels, 1 by eta B. So this is your answer. So did you understand what is like? If there is any question you can ask. Are there any questions left? So if there are no questions, we can close the session. Thank you. We'll meet next week.